In the last video, we were able to establish the relationship between indices and logarithm. And now we'll be taking more examples in regards to this. So in the last video, we established that when we have the base raised to the power of the index, okay, is equal to the number. So we are saying something like x raised to the power n is equals to y, and the related version in logarithm will be the log of the base. That means we are saying that log of y to base x is equals to the index n. So in this video we have 10 questions. We have indices to be given, in which we are going to relate the logarithm as the answer. We have the logarithm to give the indices, and it goes on and on to the last one. So you can pause the video right now and give it a try, understanding the principle that when we have x raised to the power y is equals to x raised to the power n is equals to y, then log of y to base x is equal to n. So let's begin with the first question. I have 9 raised to the power 2 is equals to 81, where 9 is the base, okay, 2 is the index, 81 is the number. So the relation in terms of logarithm, that's log of the number, that's log 81, the base, which is 9, is equal to the index, which is what? 2. Now in the second question, we have log 32 the base 2 is equals to 5. So the number is 32, the base is 2, number is 32, the base is 2, the index is 5. So therefore we are saying that the base raised to the power of index, the base is 2, the index is 5, is equal to the number, which is what? 32. So all we can see is an analogy between this relation in terms of indices and this relation in terms of logarithm. Now let's proceed. I have 4 raised to the power 4 is equals to 256. 256 is the number, 4 is the base, 4 also is the index. So we are saying that log of the number, that's log 256, so the base of 4 is equal to 4. Now let's take a step further and let's try decimal numbers. Okay, so we have the number to be 0.001, we have the base to be 10, and the index to be -3. So in this case we are saying that 10 raised to the power of -3 is equals to the number, which is equals to 0.001. In relation to this also, we are going to consider this when we get to the laws of indices, that anything raised to the logarithm of a number of the number 1 is equals to 0. Don't worry, we will deal with this when we get to the laws of logarithm. Now in this case we have the number to be 1, we have 49 is equals to as the base, and 0 to be the index. So therefore we are saying that 49, okay, 49 raised to the power of 0 is equals to 1, and this applies to the law of indices that says that a raised to the power of 0 is equals to 1. Anything raised to the power of 0 is equals to 1. This is the 0 index in indices. Now let's move forward. We have log of 1 over 27 to the base of 3 is equals to -3. Now in this case we have 1 over 27 as the number, 3 to be the base, and -3 to be the index. So in that case we have the base raised to the power of index, that's 3 raised to the power of -3, is equals to the number, that's 1 over 27. Now if we look at this closely, this follows the law of negative index, that's a raised to the power of -x is equals to 1 over a raised to the power of x. Therefore we know that this is 3 raised to the power of -3, which is 1 over 3 raised to the power of 3, that is 1 over 27. So we can see how this analogy is important. Let's take a step further. And see, 6 raised to the power 3 is equals to 216. Now, we agree that 216 is the number, the 6 is the base, the 3 is the index. And remember, we are still following this principle that when we have base to the power of index is equals to number, and we have log of the base of the number is equals to the index. So if we proceed further, then we have log of the number 216 to the base, which is 6, is equal to 3. And we have 3 more questions to go. Now in this 8th question, we have the number to be given as y, we have the base to be 10, and we have the index to be x. So in this case, remember, it is log of the number, that's log of y, to the base of x, okay, or sorry, to the base of the base, that's log 10, log y is 10 is equal to x. And in the same vein, we have log 8 as the number, 64 as the base, 1/2 as the index. So that is log of the number, which is 8, the base, which is 64, which is equal to the index, and this is 1/2. Now, if we take a look, let's look at this final question, we can see that it is related to logarithm equations. That means we are solving, this is one of the questions we'll solve when we are considering logarithm equations. So we have x squared minus 2x plus 5 is equals to 2, and it is log to the base of 2. So in this case now, we consider x squared minus 2x plus 5 as the number. We consider our 2 as the index and this 2 as the base. So we know that it is the base raised to the power of the number, okay, base raised to the power of index, okay, as we have seen here, base raised to the power of index is equal to the number. So base, the base is 2, raised to the power of index, the index is 2, is equals to the number x squared minus 2x plus 5. Now, with this understanding, we can now conclude on the topic. Let's give a quick recap and say that when we have x raised to the power n is equals to y in the index form, it is also similar to log of y to base x is equals to n in the logarithm form. So we are saying that the base raised to the power of the index, if is equals to the number, then it is equivalent to log of the number to the base is equal to the index. Right, so in our next video, we'll be taking a look at the laws of logarithm. We'll consider the addition law, we'll consider the subtraction law, we'll consider the power law, and also some additional law which are required as we deal with logarithm